presentation of my final project from structural analysis. My name is Ruben Beltran Marañon. I'm from the fourth semester of civil engineering in the Universidad Veracruzana. Well, the introduction to this project is in the civil engineering career. We have studied several subjects such as hydraulics, hydrology, works budgeting, among others. But one of the most important for our development is structural analysis. In this work, we are going to see how it is relate some topic of what we saw in the course with the SAP 2000 modeling of a building. Well, the objective of this project is that I want to talk about on this video is about how the deflections, reflections, the moments, the loads are very important when we analyze a structure. Well, the first thing we have to know is the definition of what is a deflection. The deflection is the degree to which a structural element moves under the application of a force or a load. Deflection is determined by applying the laws that relate forces and displacement. For this purpose, two methods of calculation are used, geometric and energy methods. Here, here as you can see, we have a beam and these are the loads or the forces, and it makes the deflection on it. In the model that I'm going to show you after, we have a lot of beams, and that's how it is related to this. Well, the reflection. The reflection of structures can have various sources, such as loads, temperature, manufacturing errors, or settlement. During the designs, deflections should be limited in order to ensure the integrity and quality of ceilings and preventing cracking of the materials. Here the reflection is when we have a building and some part of it falls down because of many factors like we can see here, the loads, the maybe an earthquake, some things like that are the causes of these things. We're going to talk about the internal loads. A structure with an elastic linear material response condition as to a structure that is subjected to a load will return to its original non-deformed position when the load is removed. This is like when we have an eraser and we bend it. If we don't make a lot of force, it will come back to its original form. And the deflection of a structure is caused by internal loads such as normal force, shear force, or flexing moment. We can see these elements when we are making the analysis of a beam. When we make the cuts, we can see all of these elements. The loads. A load in a beam or in a building are all the external forces exerted to the resistance elements or also their own weight. This is important. In a building, his own weight is an important force and a load. A building supports live, dead, and accidental loads. I'm going to define them for you right now. Well, now we have three kinds of loads, dead, live, and accidental. First, the dead loads. The weight of the building itself and the weight of some larger fixed equipment implements are in the dead load category, thanks to the constantly and cumulative downward force from the top of the building to the bottom. Here, as we can see, the building has a weight from himself and all of the structural elements that it has. So the building must be strong enough to support all of this. Then we have the live loads, the vibrations emitted by machinery, the force of the wind, the force exerted by seismic movements, furniture, storage goods machines, materials, occupants, and the force caused by different changes in temperature comprise the live loads. These are all of the forces and loads that the building must support, given by all of the environment we have in it and the own equipments. Like in a classroom, all of the students that are there are live loads. And accidental loads. On the other hand, seismic loads are inertial loads caused by seismic alteration that can be calculated. These are like the when we have an earthquake, we have to be prepared for that, and the building must be strong enough to support it. Now I'm going to talk you about moments. It's called the moment of a force or a torque with respect to a given point to a vector magnitude obtained as a vector product of the position vector of the point of application of the force. This is like when we have a beam in the point that we have the load or the force, we will multiplicate it for the longitude of the beam or to the origin of the beam. We can have positive moments or negative moments, like we can see in the images. Well, the application in the building that we made in SAP 2000 is that if you can see all the structure is made by beams, and here we have the to be sure that it will support all the loads, the dead loads, the live loads, and the accidental loads with a lot of strength, because we need it to be functional. And all of the beams will have a deflection, and we don't want it to have a reflection, because if they have a reflection, it will fall down. And here we have another view of the building in SAP 2000. And we have a 3D view of it. We can see all the beams that support the loads. And I think it's interesting to see how all of them will react to different kind of loads. And that's all for me. Thanks for watching this project, this video. I hope you enjoyed it, and I hope to see you soon here. Thank you. Goodbye.